Hello students, so today we will solve this question of CBSE 2022 chemistry, which is based on radiocarbon dating. So this question states that the half-life for radioactive decay of carbon-14 is 6930 years and archaeological artifact containing wood had only 75% of the carbon-14 found in a living tree. Find the age of the sample. And log 4, log 3 and log 2 along with log 10 values are also given in the question to help you solve this question. So there is a old artifact containing wood and the present concentration of carbon 14, suppose that I say R, that is given as 75% of the fresh concentration of carbon 14 which is found in a living tree. So suppose that we say fresh concentration of carbon 14 in a living tree is R naught, then concentration of carbon 14 found in that old artifact is 75% of R naught. So that means we can write it as 0.75 R naught. So this is the present concentration, and at the time when the wood of the tree from this wood artifact is coming, at the initial time the original concentration of carbon 14 will be equal to R naught in that also, but as the carbon 14 is radioactive, so it will decay with time, and the present concentration of carbon 14 in that wood artifact sample is 75% only of the initial concentration. So if initial is R naught, then present concentration of carbon 14 in the sample is 0.75 R naught. So now let's move forward and see how to solve this question. So this question is based on radioactivity, and radioactivity is a first order nuclear reaction, and so we will use the first order rate equation for solving this question. So if you know the equation for first order nuclear reaction or first order chemical reaction, that is given as time t to complete a reaction, that will be given by 2.303 divided by the decay constant or rate constant 2.303 divided by k into log of initial concentration of the reactant or nuclei present divided by current concentration or present concentration of the reactant present. So from here we will put the values. So we will get T is equal to 2.303 divided by decay constant. So in this question directly decay constant is not given, but we know the half-life of the carbon 14. So using the half-life you can calculate the decay constant as this one, 0.6931 divided by half-life. So this is the decay constant or disintegration constant of the sample multiplied by log R naught initial concentration divided by current concentration, that is given as 0.75 R naught. So from here the R naught will get cancelled, and let's put the value 2.303, and T half will come into numerator, and let's put its value, that is 6930 years given, divided by 0.6931, and it will be log 1 upon 0.75, that can be written as log 100 divided by 75, and this can be cancelled, like 25 4s are 100 and 25 3s are 75. So basically this is 2.303 into 6930 divided by 0.6931 into this is log 4 upon 3, that can be written as log 4 minus log 3. Now log 4 and log 3 values are also given in the question, so let's put those values and solve this. 2.303 into 6930 divided by 0.6931 into log 4 is given as 0.6021 minus log 3 is 0.4771. So now solve this and see what we will get. So on solving this expression, the final value we are getting, that is 2878.33. So we will simply write 2878 years because only 4 significant figures are given in the half-life of the sample given in the question. So final answer will be 2878 years. So the age of the tree from which this old artifact has been crafted is approximately 2878 years, and that will be the answer to this question. So I hope you understood this question, and if you have any doubt, please ask me in the comment section. I will definitely try to answer your question, and consider liking my videos and subscribing my channel also.